All right, welcome to section 3.3. It is about probability distributions and discrete probability distributions and those little tables. So we've been working with probability a little bit, and I just want to highlight a couple of things here just in case. These capital X's and Y's are going to denote random variables. And then the little X's and Y's, they're going to denote values of those variables. So there's a little bit of rationale here. The X is the number of heads when you toss 3 coins. And so these would be your outcomes, what they look like. The values, you'd have 0, 1, 2, or 3. Anyway, we get a probability distribution function. And a lot of times we put those in tables like you see down here to make it easy to understand. Now these are all outcomes over here and probabilities here. So probabilities need to be between 0 and 1 inclusive. So they can't be negative and they can't be bigger than 1 because they're really how often something happens. Now a probability distribution table or a PDF table like this, it should have all the outcomes here, and it doesn't necessarily mean that they flow. It could be that it's 0, 5, 10, something like that. And then it should have probabilities for those. And these probabilities, if this really is a probability distribution table, easy for me to say, these probabilities will add to 1. Now there is a small chance, if we have some rounding error, that they'll be really, really close to 1. But say we have 4 things over here, so these should be within 4/100ths of 1. And oftentimes 1 would round up and 1 would round down, so they should be really, really close to 1. Now, the mean of a probability distribution function is what we call this expected value. And that's what would happen if we did this a bunch of times. And so for the mean here, mu, it is the sum of all the x times p of x's. So I'll do some of these in a minute here, like we would in WAMAP. But I just want to run through the formula so we have those for the mean and the standard deviation. So anyway, all the x times p of x, we sum those up and that's the mean. Now the standard deviation, just like we were finding the standard deviation earlier, we find these deviations, so we take each data point, subtract the mean, we square those, and we multiply them by their probabilities. Then we sum those up and take the square root. So these are the formulas you're going to want to kind of commit to memory out of this. The Excel functions won't work correctly here. So you got to make sure that you use these formulas for finding the mean and the standard deviation of a probability distribution function. So to that end, let's see if we can't find some problems to do. So here's a question out of the WAMAP section. So is this a probability distribution? So yes or no. So we have outcomes over here, we have probabilities here, and we could just grab this. So I'll copy it and go to Excel. Maybe I'll set them up side by side. Maybe. And really we're interested, does this add to 1? Now I grab it here, notice sum is 1, we're good. If I want to figure out to be a little more, okay, I'm going to show my work. I'll grab the sum here, and it should be 1. So that means it is a probability distribution function. Now this sum could go to 1 and not be a probability distribution function if these values weren't between 0 and 1. So in this case, we have all values between 0 and 1, and they sum to 1, so we're set. Here we have these. You might be able to add these in your head. That's okay. 0.3, 0.1 is 0.4, 0.45, 0.55. Looks pretty good. But the question here, what is the mean? So what is the mean? I'm going to grab the data here, and I'll start a new sheet. Paste it. Zoom in a little bit. For the mean, we want x times p of x. And what that looks like here is this column multiplied by this column. And write it down. And then the mean here, mu, is the sum of these. That's that formula we had, the sum of all the x times p of x. So this is our mean here. It says round to 1 decimal place, 1.9.